In this video, I'll be going over how you can integrate Kafka into your FastAPI applications to create an event-driven application utilizing messaging. You can use it for various tasks such as log aggregation, real-time analytics, and integrating microservices. I know for my job, I used it for real-time payments, so Kafka has a lot of ways that you can use it with your application for useful messaging. And this can all be done by leveraging an asynchronous approach, which will allow for high throughput and low latency delivery. So to start off, I will show how to create a running instance of Kafka and Zookeeper using a Docker Compose file. And then we'll get started developing our Kafka producer and Kafka consumer in our FastAPI application. So let's get started. So here I have Visual Studio Code open, and we will need two containers and they depend on each other. So I'll be using a Docker Compose to spin it up in the proper order. I'll be using Kafka and I'll be using Zookeeper. Zookeeper handles the coordination of a Kafka cluster. I'm not going to go too deep about Kafka and Zookeeper because I do have a whole video on that topic, which I'll leave a link to. Now let me open up the Docker Compose and I can go over what you will need. So first in the YAML, I have a version. Right now it's version 3.8. Then secondly, I have the services. These are the services that I want to spin up into a container. So I have Zookeeper and I have the broker, which is going to be Kafka. Now let's start off with Zookeeper. So I specify the image that I want to use to spin up the container. So I'm using the Confluent inc/cp-zookeeper, and I'm defining that I want the latest version of that. Then secondly, I'm defining the container name, which I want to call it Zookeeper when I spin it up. And then there are some environment variables that I'm setting up in the environment section. So the Zookeeper server ID, which I specified as 1, just uniquely identifies each Zookeeper server. And it must be unique, and the value that you could choose is between 1 and 255. Now the Zookeeper client port just instructs Zookeeper where to listen for connections by clients such as Kafka. So I don't want to get too far into it, but we can see here we have another environment variable that lets Kafka know where to connect with Zookeeper, which is on the same port that we defined here. And the next thing we have is a Zookeeper tick time, which we set to 2000, which essentially is like a health check. So every 2 seconds, we're going to check, is the host okay? Is the host okay? So that just allows to check if the host is running as expected. And here we're defining the ports. So on the host machine, we're defining it to run on 22.181. And if we make any calls to this port on the host machine, it's going to direct it to the internal port of 2181, which is the port of our Zookeeper instance. Next thing we have is the broker, which is just Kafka. And the image we're going to be using for that is the Confluent inc/cp-Kafka, and we're using the latest version of that. And the container name I'm using is broker. And the ports I'm defining is 9092. So on the host machine, it's going to be 9092, and internally it's going to be 9092. And this is where the dependency comes, right? Because we need Zookeeper to start up first before we can start off our Kafka container. And we use this key of depends on to let this Docker Compose know that, okay, this Kafka broker or this broker container is going to be dependent on Zookeeper. So make sure that's running first before we can run this Kafka instance. Then we have the Kafka broker ID, which is just a unique identifier for the broker. We have the Zookeeper connect, which I defined as the way to connect to Zookeeper, which we created above here. And then we have the Kafka listener security protocol map, which just defines a key value for the security protocol to use per listener name, which in this case we're just defining as the plain text for the key and the value. And then we have the Kafka advertised listeners, which just makes Kafka accessible from the outside of the container by advertising its location on the Docker host, which we're defining as localhost 9092. And then lastly, we have the Kafka offset top replication factor. This is required when you're running with a single node cluster, which in this case, we're just going to supply with 1. So yeah, that's all that we're going to need to spin up the Zookeeper container and the Kafka container. But just know that we need these two to actually spin it up because Kafka is dependent on Zookeeper. So to spin it up, we can do a Docker, and you got to make sure that you're in the same directory as the Docker Compose, and make sure that your Docker instance is running. So make sure you have that well, or you can run Docker PS, and you can see what's running. So let me open this up a little bit more, and let me clear this out. And what we can do is we can do a Docker Compose up -d. What this is going to do is it's going to run this Docker Compose command, and it's going to spin up our containers based on the specifications that we provided. And it's going to run it detached because we defined the -d flag. So let's press enter, and it's going to start to spin that up. And it's going to create a default network with the name of the folder that it's in, which in this case is FastAPI-Kafka, because it's going to group these containers. Now if I run Docker PS, we'll see that it just started up 15 seconds ago. It's running. You can see that the ports is showing that it's 992 on the host and internally, and it's going to establish that connection with a TCP port. You can see the same thing here with the Zookeeper instance. And I have a Postgres instance that I've have running for the past 3 days. But yes, this is how you spin up a Kafka container and a Zookeeper container, and they're dependent on each other. Now we can start the process of getting information into Kafka, and we have to create a topic to actually send messages to and allow for applications to consume from that topic as well. So we'll create the producer, the consumer, and we'll find a way to create a topic using Python. I will be creating 2 FastAPI applications to get the full usage of Kafka messaging between applications. I'll be creating a producer, which will place messages on a topic based on a text set from a request. And I would then have the consumer continually poll to check for any new messages that appear in the topic. This will allow us to keep track of any new relevant data and process it how we want to. So first, let's create the producer. So let's create a folder. I'm going to call mine FastAPI Producer. And let me cd into that FastAPI Producer folder. And I'm going to create a virtual environment because I need a couple of dependencies. So I'm going to do Python 3 -m VNV, and I'm going to call the virtual environment VNV. And what I can do is I can do source, and I'm going to do /VNV bin activate, press enter, and let me do which Python to confirm which Python I'm using, and I can see that it's the virtual environment one. Cool. So let me clear that out. And let me go ahead and install the dependencies that I need. So I'm going to do a pip install, and I'm going to need FastAPI standard, and I'm going to need Kafka -Python -ng. Press enter. And the Kafka Python ng is a Python client for Apache Kafka, which is going to allow us to communicate with our running Kafka container using Python. So now that that's installed, let's go ahead and create what we need, the starter code. So let me clear this out. So the first thing I'm going to do is I'm going to create the schema for this producer application, because I want the user, or I'm going to allow the user to send a request with a message, and we're going to take that message and we're going to place it into the Kafka topic. We're going to send it to the Kafka topic, and I want to make sure that the user sends a proper message. I want to make sure it's in the proper format and it's been validated. So that's why the schema will be important. So I'm going to do touch produce underscore schema.py, and that should create that file in this folder. Now in this file, I'm going to do from Pydantic import base model and field. Now with that, I can do class produce message is what I'm going to call it. And I'm going to inherit from the base model from Pydantic. And I'm going to specify what I expect this request to look like when the user sends the request. And it's only going to be one field, and that's going to be the message. And it's going to be of type string, but I want to clarify how I expect the string to look like. So using fields, what I'm going to do is I'm going to open that up, and you can see that it comes with a lot of things that we can utilize, but I'm only going to utilize 2 for now. And I'm going to use min length. So min underscore length. And I'm going to see that this has to have at least one character. And max wise, I could define max length to be equal to whatever I want. I'm going to define it as 250. So essentially this is saying that the message has to be at least one character and up to 250 characters, right? So this helps with making sure that nobody sends anything malicious, right? You may have somebody that may intend to break your application, right? So they may send something that's really big. And if you produce a message, I'm sure, to a Kafka topic that's way too big for it to produce or for it to take, then it's going to cause problems. So making sure that the message is in the proper format, that it's the proper size, this is perfect for that. So now that we have the schema, we can go ahead and work on the producer functions, right? We want to make sure that we can connect to Kafka and be able to produce messages to Kafka. So let's go ahead and do that. So I'm going to create another file. I'm going to call that Kafka producer. And let me go ahead and do touch Kafka underscore producer.py. And here it is. So let me start off with importing what I'll need. So from Kafka, let me import Kafka producer. From FastAPI, let me import the HTTP exception. From the produce schema, import produce message, and let me import JSON. Nice. Now let me create some constant values that we'll utilize throughout this file. So I'll just call this constant value section. And first off, I want to do the Kafka broker URL. So that's going to be the location of where our Kafka instance is, right? So we know that it's running on localhost 9092. That's what we assigned the port to be, and that's where we're going to connect to our instance that is running. Then there's the Kafka topic, and that's going to be equal to FastAPI -topic. Now you can name this whatever you want. We're going to create it based on this name, and we're going to connect to it based on this name. Just make sure that, it's consistent. Next, I'm going to do the producer client ID, which is just the client ID for our producer. It's just a unique identifier for our producer. And that is going to equal, I'm going to call it FastAPI underscore producer. Now, the next thing I'm going to define is the serializer. So before sending the message to the topic, we're going to serialize the information, make sure that it's in the proper format. So I'm going to create a function called serializer. I'm going to take in a message. And then what I'm going to do is I'm going to return JSON.dumps, which is going to take our message, which is going to be a dictionary, and it's going to turn it into a JSON string. And we're going to encode that. And by default, it's going to default to UTF-8. Next thing we'll do is create an instance of a Kafka producer. This is going to establish the connection and allow us to send messages to Kafka. So producer is going to equal to Kafka producer. Open that up, specify the API version, and that's going to be equal to 080. This is the one that works for me. And then bootstrap underscore servers is going to be equal to the Kafka broker URL, and then the value serializer is going to be equal to serializer, and then the client ID is going to be equal to the producer client ID. So the API version, the bootstrap servers, which is going to inform where to connect to Kafka, which is just this localhost 9092. The value serializer is going to serialize our messages, and then the client ID is just going to be the specific client ID of the producer. So it's like an identifier, unique identifier. Then lastly, we're going to create a function that produces a Kafka message. So it's going to allow us to send off a message that we provide to a Kafka topic, because we already used this to establish a connection. Now we can specify what topic to send the message to and what is the message that's being sent off. So let's do produce underscore Kafka underscore message, and this is going to be a message, and the format of the message is going to be produce message. And what we're going to try to do is do producer dot send, and we got to specify the topic, and in this case we have a constant for that, so it's going to be Kafka topic, and what we're going to do is json.dumps, and we're going to have a dictionary of message and specify that the message is going to be the message here, and we're good to go on that front. Now the second part is going to be up to you, but if you want to make sure that all the messages are sent, you want to ensure that it's sent, you can do producer.flush. But really, this is up to you. And let me just put a comment: ensures all messages are sent. Now let's close off the except with exception as error, and we'll go ahead and print the error. If you have a logging mechanism, go ahead and log that here, and we can raise, and on the next line, of course, raise an HTTP exception with the status code of 500. It's more of an internal issue if our Kafka instance is unable to send the message. And then we can go ahead and provide a detail of failed to send message. Cool. So that's the logic of, first of all, just establishing the connection with Kafka, utilizing this Kafka producer from our Kafka Python ng dependency, and then actually producing it with that instance of the Kafka producer that we created. Now the issue is we're using a Kafka topic, which is FastAPI-topic, that doesn't exist yet, right? We have a spinning Kafka container that's running with Zookeeper, but we don't actually have a FastAPI-topic that is running, right? So if we try to send a message to this topic, it's definitely going to break. So we'll work on that now in the main.py, which is the entryway. So let me go ahead and create that file, touch main.py, go into here. So let me go over what I'll be doing in this main.py, right? So what I'm going to be doing is utilizing a thing called lifespan, which is going to allow us to have access to the application before it officially starts taking requests. So we're going to do the initial setup of the topic, right? So what we're going to do is check if we already have a topic available by the name of FastAPI-topic. If we do, then we can go ahead and continue with the start of the application. If not, then we're going to create the topic and then continue on with the creation of the application. So we're going to utilize lifespans for that. So let me go ahead and import all the necessary things that I will need. So let's do from FastAPI import FastAPI background task, because we're going to be sending off these messages in the background because we don't want it to be a blocking task. We want it to be in the background so we can continue to take other requests. So from Kafka.admin import KafkaAdminClient, which is going to allow us to create, update, delete topics. And I know we'll be creating a new topic, so we're going to also get that. And then from Kafka producer import produce Kafka message, because we're going to be creating an endpoint, and when a user sends a message, we're going to be utilizing the produce Kafka message to send that message off. And then from context lib, we're going to import async context manager. We'll be utilizing this for the lifespan. And then from produce schema, import produce message. We want to make sure that the user sends a request that's in the format of produce message schema. And then we'll define the constants here. So constant section. constants, and then go ahead and do Kafka broker. And honestly, let me just save my time and just go ahead and take the first two here, paste it over here, and do Kafka admin client is equal to fast API admin client. And this is just going to be the ID of the admin client that we're going to be creating an instance of to create the topics. And I'll show you guys how you can delete a topic as well. So let's do the logic of the lifespan first. Let's go ahead and do @async context manager. And we're going to create an async function. And that's going to be a lifespan. It's going to be called lifespan. And it's going to take an instance of app, which is the FastAPI instance. And then open that up. And now we'll start defining the logic of creating a topic on startup of the application. So what we're going to do is create an instance of admin_client, and that's going to be equal to the Kafka admin client. Open that up. And the two things we'll need is the bootstrap servers, which is going to be equal to the broker URL. It's going to help establish that connection. And then the client ID, which is just going to be equal to the Kafka admin client. So now we have an instance of the Kafka admin client. What we can now do is check, are there any topics within Kafka that has the name of this Kafka topic? So what we can do is, if not Kafka topic, in the admin clients dot list underscore topics, right? So what this is going to do is provide a list of all the topics in our running Kafka container. And if this Kafka topic is not in this list of topics, then we can go ahead and create it. So let's do admin client dot create, and I'll create underscore topics, and we can define what this topic will look like. So new topics is going to be equal to a list, and we're only going to be creating one topic, but it's going to be of type new topic, and the name is going to be equal to Kafka topic, which is going to be FastAPI dash topic. And then we can define other things, and luckily if you have VS Code, you should see some of this. You can see what you can configure, but the number of partitions is one of them, and I'm going to set that equal to 1, and the replication factor is going to also be 1. Keep it very basic. And that's pretty much all we're going to need. It's going to create a new Kafka topic with the name that we defined as Kafka underscore topic, which is FastAPI topic. And it's going to define the number of partitions equal to 1 and the replication factor to be 1. And then one more thing we're going to need is ensuring that the validate only is going to be equal to false. So if it's true, don't actually create new topics. But if it's false, which is default, is going to be false, but just in case, I'm going to set it to false. Now, just for educational purposes, if you want to delete topics, what you can do is with that same instance of admin client, right? Admin underscore client in this case, you could do dot, and let me just remove it from the comment so it'll be easier to see. You do dot delete topics. It's right here for me. And open that up. It'll be topics equal to, and just define a list of what you want to delete, which in this case is going to be Kafka topics. So this is how you delete topics if you want to, but I don't want to delete it. I want to create it if that topic is not in the list of topics. If it is, then it's going to skip over that logic and it's just going to continue on. Now, with the nature of lifespans, we're going to have to use a yield here, and this is the separation point, right? So anything before this yield will be ran before the application starts taking requests, essentially when the application starts up. And then anything after this yield will be as the application is closing. So if you need to do any cleanup, you will do it after this yield. I always call this the separation point. So that is that. And now we have to take this lifespan and inform the application about it. So we can do app equal FastAPI, and we can do lifespan is equal to lifespan. Nice. All right, so now it's up to the last piece of code, which is going to be the endpoint. We want to accept the message from a client so that we can send off to the Kafka topic. So how we can do that is using the @app.post to define an endpoint, and I want to give it a name of /produce/message. And I'm going to define tags, and let me add one more /, and let me define tags to add a specific section in the documentation. And I'm going to call this produce message. And the function for the endpoint is going to be async because we're going to be running some background tasks, and that's asynchronous. And we're going to do produce_message. That's the name. Define that we want the message request to be of type produce message. So that's going to accept a request that is in the format of the schema that we created. It has to be a string of length 1 up to 250. Nothing less, nothing more. And then we have to inject the background task because we want to utilize it in our endpoint. And then let's go ahead and utilize really quick. So background task.add task, and what this is going to allow us to do is run something in the background, right? It shouldn't block our code. It's going to run in the background and complete in the background. So how we can specify what we want to run in the background is first by defining the function that's going to run in the background, which is going to be produce Kafka message, and then defining the parameters that this task is going to need to run. So we're going to need the message request. And that's pretty much it. If you have more parameters, then you can define it by putting a comma and defining the parameters. Or if you have no parameters, then you can just remove this. But in my case, I only just have one parameter, which is the message request, and I'm good to go. And then finally, I'm going to return just a JSON informing the user that, thank you for sending a message. So message is going to be message received. Thank you for sending a message. Cool. So that's pretty much it, right? We have this asynchronous endpoint, right? It's gonna accept a post request, and we expect the message to be in the format of the produce message schema. And we have a background task that will run the produce Kafka message function in the background, which will accept a message request and send that off to the topic. And we're informing the user that we received the message. Thank you for sending a message. So we can test this out. Let's actually run this. So FastAPI dev main.py. And now what we can do is we can go to this URL here and check it out. So here I am in the docs. We see the produce message section. Let's open this up. We see that the format is message and of type string. We can try this out. I can change up the string here to sending a nice message. Press execute. And let me see here. Boom. Message received. Thank you for sending a message. So let's go back to the application and see the logs really quick. And I already know the issue. So I'm going to keep this in just to inform you guys, just in case you have it, already set up like this. But if you go into the Kafka producer, I am accepting the produce message schema, right? This is going to be of type produce message, but I need to actually grab the message inside, right? So it's going to be message, and I'm going to make this more specific, message request, just to add some clarity. And I need to make sure that I extract the message from the message request. So this should work. And let me go back to the doc and run it again. So we received the message. Let's go back and check. And boom, we got no errors. We are good to go. And that will be also another thing, right? We can see that the error didn't block the application. It didn't break the application. But you have to have a way to handle errors, right? So if there are any exceptions, you may want to implement some type of retry logic, or maybe even have like an alert to send out to make sure that someone checks what's exactly causing the issue. So At least we got to see an edge case of what can occur if there are any errors in a issue that's being sent in a background task. But just make sure that you extract the message from the message request from your schema, and it should be good to go. So let's go ahead and create the consumer, because now that we have messages on the topic, we should be able to consume those messages and do what we want with it, right? We can process it, put it in a database, or just print it out. We can do whatever we want with the data once we consume it. So let's start that process. So what I'm going to do is start the process just like how we did with the FastAPI producer. Let me close out these files. I'm going to create, and let me close out the terminal really quick and clear it. I'm going to create another folder, right? So here I'm going to create a new folder called FastAPI-consumer. And what I'm going to do is I'm going to create a virtual environment here. So let me do deactivate. And what I'm going to do is I'm going to cd into the FastAPI consumer. And I'm going to do Python 3-m vnv vnv, right? And now what I can do is source and then /vnv bin and activate it. So now that we're activated in our consumer, I can go ahead and install the dependencies I'll need. So it's going to be essentially the same dependencies as the producer. So I'm going to do pip install FastAPI standard and Kafka Python ng. Cool. Now let me clear this out, and what I'm going to do is I'm going to create a main.py. So let me do that, touch main.py, and let me close this out and open this up. And let me see, it's because I put it together, touch main.py, and here we have it. So I'm going to start off with the initial imports and things that I need. So from FastAPI, I'm going to import FastAPI, and then I'm going to import Asyncio because we're going to be running some things asynchronously using threads. So let me do that. And then from Kafka, I'm going to import Kafka consumer, and I'm going to import JSON because we're going to have to load that data that's on the Kafka topic. And then now I'm going to define some constants that I'm going to utilize. So constant section. First one is going to be the Kafka broker URL. If you remember, that's what we're going to use to establish that connection with our Kafka instance that's running on localhost 9092. And then I have the Kafka topic, which I want to consume from, which is going to be equal to FastAPI-topic. Then I have the Kafka consumer ID, just identifier for the consumer. So I'm just going to call this FastAPI-consumer. Cool. So now we got the constants that we need. Let's go ahead and start actually implementing some code. What are the intentions of this consumer application? Well, we will be creating two endpoints. One to trigger the consumer to start polling. Polling meaning that we're constantly going to listen for any changes on the Kafka topic. So if we send anything using the producer, the Kafka consumer is going to listen to the topic and make sure that we consume those changes. So we're going to use a trigger endpoint to start the listening of that topic using polling, and any new changes will be consumed and processed after that initial trigger. And we'll be using Asyncio. I think I'm pronouncing that. And we'll be using Asyncio. I hope I'm pronouncing that properly, but Asyncio to start the process and have pauses in between to handle any other processes that FastAPI needs to do. And Asyncio will be useful for starting the polling and stopping the polling. So it will work as a flag, essentially. So let's go ahead and create that flag. So we're going to create a stop polling event underscores in between, and it's going to be equal to an Asyncio dot event. And if you go here, you can, if you have VS Code, you can go here and see a little description about it. But it's a flag that can be set to true with the set, and we can reset it to false with the clear method. So we're going to be using this to start the polling event and stop the polling event. So once we set it, we know that we're stopping the polling event. And if we want to restart it, we're going to reset it. Cool. And let's actually create an instance of FastAPI, and that'll be there. And then now we're going to need the deserializer. Remember, we created a serializer in the producer application, right? We serialized it. We created a JSON string and we encoded it and put it into the Kafka topic. Well, now we're going to have to receive that and decode it. So let's go ahead and create the deserializer. So let's do def, and I'm going to call this JSON underscore deserializer. And it's going to take in a value. And what I'm going to do is, if value is none, there's nothing to deserialize, then I'm just going to go ahead and return. If not, I'm going to go ahead and try to turn this string, this JSON string, into an actual object. So I'm going to do try JSON, and I'm going to return whatever that I try to do. So I'm going to try to do JSON.loads, and I'm going to do value.decode. Remember, because we encoded it, so we actually have to decode it. And I'm going to specify I'm going to decode the UTF-8 of the value. All right, so decode it and then load it. Now, if there's any issues, then we can do the except, and we can just print out unable to decode. And we're going to return none, right? We don't want to return anything because we're unable to decode it, so just go ahead and return none. And we can return none here too. So now let's create a helper function that's going to allow us to initialize a Kafka consumer. Because remember, we created an instance of a Kafka producer in the producer application, but here we're going to create an instance of a Kafka consumer. But we're going to put it in a function because there are times where we're going to stop and close the consumer because, you know, we're using a trigger, right? Polling. So when we trigger the application to start polling, we're going to create an instance of a Kafka consumer. But when we detrigger the consumer, meaning stopping the polling, we're going to close the Kafka consumer. But then we're able to trigger it again, which we're going to need another instance of a Kafka consumer. So because we're going to need to either initialize the consumer multiple times or close the Kafka consumer multiple times, we want to be able to do it pretty easily. So we're going to use a function for that. So we're going to do create Kafka consumer, open that up, and I'm going to call this consumer equal to Kafka consumer, and we can define the Kafka topic, the bootstrap servers, and we're going to make that equal to the Kafka broker URL. Then there's a property called auto underscore offsets underscore reset. And we're going to set this to earliest. Now, what does this mean? It's just going to mean that it's going to start reading at the earliest available message. So whenever a producer sends something to the topic, the earliest message will be read first. And then what we're going to do is enable the auto commit. Set the true. So it's going to auto commit the offsets automatically. Then we're going to assign the group ID. And if you want to know more about, properties that Kafka requires, I have a whole video on Kafka that I'll leave a link to. Group ID is just as the name implies, it's just the consumer group ID, which we defined above here. So I'm going to use the Kafka consumer ID. And then the last thing I want to define is the value deserializer. And I'm going to assign it to the JSON deserializer that we just created. So this is all we need to create an instance of a consumer. And let's go ahead and return the consumer. Go. We will now create the logic to poll the consumer. It's going to accept a param of a Kafka consumer, which is why we created this function right here of create Kafka consumer. And in a try and accept, we're going to first check if there is a stop polling event set. If it's not set yet, then that means we can continue polling. Because remember, we made that stop polling event here. Remember, if it's set, then it's going to be considered true, right? Meaning that means in our case, it's going to stop the polling. But if it's not set yet, that means it's going to continue polling. So let's go ahead and start that process of creating the polling logic. So async, it's going to be asynchronous function, and then we're going to call this poll consumer, and we're going to accept a consumer of type Kafka consumer. Now we're going to open up that try, and while not stop polling event is set, we can go ahead and start polling. And I'm going to create like a little inner log to show that it's trying to poll again. And this is going to make much more sense when we actually start the application and start to see it running and see how many times it starts printing this out, because it's just going to show that the consumer is constantly listening each time. The next line that I want to add is utilizing the consumer.poll. So records is going to be equal to consumer.polls. And I got to define two things. Well, I don't have to, but I'm going to define two things, right? First thing I could define is the milliseconds that I want the consumer to wait for new data in the buffer, right? So I want this consumer to wait for 5 seconds, right? If any new data arises in that 5 seconds, capture that, right? And that's going to be captured in this records variable. Now, the second thing I could define is the max amount of records that I want to hold, right? So say for instance, somebody places or something like our backend, our producer produces 2,000 messages and place it onto our topic. But maybe we don't want to consume 2,000 at a time, right? Maybe we want to just consume 500 at a time. Well, we could define the max amount of records that we want to pull for. So I can place a value here that defines the max amount of records that I want to pull at a given time. Now, if we just define 0 or define nothing, it returns immediately with any records that are available. So if you just want to receive everything that's on the topic, then that's fine. But I want to make sure that this application doesn't get too overloaded. So I'm going to keep it at 500 or maybe even 250 at a time. Granted, I don't expect to send that much, but this will be useful if you want to do some testing to see how much your application can take. And if you see that your application can't take too many records, then you can define the maximum records here. Now that we know that there may be records here, right? Because we're polling, we're telling the consumer, wait for 5 seconds and see how many records you're able to retrieve. And we got to check. Maybe in those 5 seconds, there are no records. So then we don't need to iterate anything, right? There are no records. But if there are records, then we can go ahead and grab the values, right? And the format of the records is going to be in a dictionary. So we have to grab the values of each record. So we can do for record in records dot value, right? Then we could process the messages in each record. So for message in record, we can do M is going to be equal to JSON dot loads the message dot value. And we're going to do dot get, because remember we sent it as a JSON with a key of message. So remember, we're just loading it into a JSON and then we're grabbing that key by message. And then we can go ahead and print out the message that we received. I'm going to use a format here. So F received the message, and we can go ahead and inject that message that we received from the topic of message dot topic. Go. And then one thing that's cool about asyncio, and I still hope that I'm pronouncing that properly, is that we can use await asyncio dot sleep. And what's cool about this is going to allow us to pause here, right? Pause our asynchronous code and finish up any other events that are happening in the loop thread. So maybe we don't want this to continually keep going. We can give it some time to just sleep for a little bit and then process any other things, any other threads, and then we could continue this process of polling. So whatever time you feel like you want to pause, or maybe you don't want to pause, that's fine, but I'll give it a pause of 5. And then we can go ahead and close out this except. So I'm going to do except exception as E, and I'm going to print a formatted string of errors available, and then inject that error. And finally, we got to make sure that no matter what, we close the consumer. So whether there's an issue or whether the stop polling event occurred, right, we got to close the consumer. And that's the reason why we created this function, right, of create Kafka consumer. So in the case that we do close the consumer, we can go ahead and call this function again to open it back up and utilize it again to start the polling. And before that, let me go ahead and print out that we're closing the consumer. Now we can go ahead, now that we have the polling logic for the consumer, we can go ahead and create the 2 endpoints that I was talking about. One endpoint to start the polling process. We're going to trigger the polling. And the second endpoint to stop the polling. So let's create the first one of starting the polling. So we're going to do @app.get. And really, we don't need the user to send anything. Just know that if you send a GET request to this trigger, then we're going to start up the polling events, right? And then we're going to create this as a async function. We're going to be using asyncio in here. And we're going to do trigger polling as the name. And then we can start the logic for this. Now, what I'm going to do is create a task list. And I'm going to define it here. And essentially what this is going to do is I'm going to store all the current tasks, right? The task is going to be the polling process. So whenever I start a polling process, I'm going to insert it into the task list. Now, whenever somebody sends a GET request to this trigger, I want to check, is there currently a polling task already in the task list? If so, then I can ignore that trigger request because I already have a task list that's already have a task in the task list that's already polling the consumer. If no values are in the task list, then I can start that process of creating that polling event. So this is just a way to make sure that I'm not creating additional tasks that I don't need to, right? I just need one running at a single time. I don't need multiple. If not task list, meaning there's nothing in the task list, what I can do is I'm going to make sure that I clear out any polling event. So maybe it was set before and it wasn't cleared out. I want to reset it, right? So I'm going to do clear, and I'm going to leave a comment of this resets the flag. So that means I can go ahead and now when I create the consumer and I start that polling consumer function, this polling event is going to be cleared out, reset, and now it's going to start that process, right? This is going to allow us to go ahead and run this polling portion. Because remember, if it is set, this is going to be equal to true, and not true is going to be false, which is going to pretty much close this out. So make sure that I reset it, make sure that it's not true, and we're good to go in that process. Then I'm going to create an instance of a consumer, right? Luckily, we have a function that's going to allow us to create a Kafka consumer, and then I'm going to define the task that I want to be doing on a thread. So task is going to be equal to asyncio dot create task. And what I'm going to do is I'm going to pass this function of poll consumer as the task. And I'm going to pass in as the param consumer equal to consumer. Cool. And now that I have this task, I'm going to go ahead and append that to the task list to make sure that if someone's going to get request to this trigger again, I'm not creating another task that I don't need. So go ahead and do this. And then now, lastly, I can go ahead and return a JSON informing the user that we began the Kafka polling process. So Kafka polling has started. Cool. Now, if there already is a task in the task list, we can go ahead and return that the status is going to be that Kafka polling already triggered. So if there's not a value in the task list, go ahead and start that process of creating a polling process and then append it to the task list. And if not, then go ahead and return the fact that, this Kafka polling was already triggered. Cool. So now we need to create an endpoint to stop the polling event. So what we can do is at app.get. I just need a request to let me know, okay, I can go ahead and stop that. So stop trigger or dash trigger. And I'm going to also make this an async function. And I'm going to call this stop trigger. And this one's going to be relatively simple, right? It's going to be stop polling event dot set. We're going to set this to true because if we set this to true, this is going to stop the while loop and it's going to go ahead and close the consumer and it's going to stop the polling. And if task list, meaning that if there's any value in the task list, we can do task list dot pop. And what we can do is inform the user that the polling has stopped. So return status of Kafka polling stopped. So that's pretty much it, right? We stop the event, it's going to close the consumer for us, and then thus that whole function is going to already end, right? The polling consumer is not going to be ran again because it's going to stop. And then we can pop out that task from the task list, and then we can return the fact that it stopped. So when we get back to triggering it again, there's not going to be a value in the task list. We can go ahead and create that process again and inform the user that it has started already. And we can go back and forth with this if we want to. So that is the logic for the consumer. Now let's go ahead and test it. So let me open up another terminal and let me cd into the FastAPI producer. And let me actually get that started. So I'm going to do FastAPI dev main.py and I'm going to specify the port. So let me do port 8001, right? Because I'm going to run this twice. So you can use -- port and then specify the port that you want to run it on. And that should be good to go. And then let me run the FastAPI dev main.py -- port on 8002 for the consumer. So I already realized that I made a mistake. Is .values, not value. Is a dictionary is .values. Stupid mistake. I'm wondering what's going on. But yeah, .values, not value. So if you're having that issue, just a little clarity. It's in the poll consumer function. Use records.values. All right, so let's go ahead and test that. So let's go ahead and trigger it one more time. started. Let's execute. So I'm going to send a whole bunch. And let's go back to the logs and see what happens. Boom, boom, boom. All right, then. So as you can see, we received a lot of messages, right? And you can constantly see, okay, we're trying to poll again. We're trying to poll again. It's gonna retrieve the records, output it, and it's gonna start that while loop again. And we can see that it didn't receive any new messages, so it didn't print out anything else. But if I go back to the producer, it's going to print out everything at its earliest convenience, and then it's going to start that process again of polling. So that is just the power of consumption, right? This is how the consumer works. This is how the logic for this consumer works. It's going to constantly poll, right? It's going to wait and see how many messages were sent in this 5-second period, right? Because I defined it as 5,000 milliseconds here. And if it is, less than 250 or up to 250, we can grab that and send it at one time. If it's more than 250, we're gonna have to get that in the next batch because the maximum amount at one time that I can retrieve is 250. But I can increase that, of course, if I want to. And then it's gonna go ahead and iterate the records that was retrieved during that 5-second period, load that information, print that information, sleep for 5 seconds, allow for other threads to do their thing, and go back and try that polling process again. So you can see that it's going to continue going and going until I stop it. So let's go ahead and stop the polling process. So here I am back in the docs for the consumer. I'm going to close this out and go ahead and stop the process by just sending another GET request to the stop trigger endpoint. So I'm going to execute that and Kafka polling stop. Let's go back and see if that's true. And then boom. As you can see, got a GET request, got 2 GET requests to stop the trigger, and we can see that it closed the consumer, and we don't see that trying to poll again message anymore. But if I start it up again, let me see what happens. Kafka polling has started, and it's trying to poll again, right? And it's going to continue doing that until I stop it again with the trigger or until you close the application. And I can change the message, send a whole bunch. I'm just saying like 30 or 40 and go back. Look at that. Hello Tech family, and it's going to keep sending and sending it. That is the power of the producer, and that is the power of consuming. And you can see how powerful this is when it comes to messaging with other applications, because I can go ahead and receive messages from another application and process it in my consumer application, or send it even more downstream to other applications by using another topic. So that is the power of Kafka, and utilizing the producer, utilizing the consumer, and even utilizing the admin client to create a topic, delete a topic, or even update a topic. So hopefully you guys got something out of this. You learned the full scope of everything, and go ahead and play around a little bit more with it. Maybe you might take this data that you receive from the consumer, process it, put it in a database, or like I said, send it down to another system. So thank you for watching.